this video, I'll walk through the process of using transformations to graph a parabola. Here's the problem. It said use transformations of the graph f of x equals x squared to determine the graph of the given function h of x equals the opposite of x minus 2 quantity squared. Notice that negative, the opposite, is outside the parenthesis. So we have two different transformations going on here. We've got the negative out in front, the opposite, and we have a -2, a -2 inside the parentheses. So let's break this down. I'm going to start by looking at the graph of f of x equals x squared. Here I've done that ahead of time, did a little chart here, a t-chart, to show that when x is -2, -1, 0, 1, and 2, we get the -2 squared. Notice that that's -2 times -2, so that's +4. -1 squared, -1 times -1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Plotted those points. I also included when x is 3, y is 9. Notice that when x is 3, y is 9, and when x is -3, y is 9 again, right? And so on. So I could label each of these ordered pairs pretty easily. And by the way, did you notice that this is an even function because we have symmetry on this axis, on the y-axis? There I've labeled those points. But in the future, you should be able to graph this h of x equals x squared without going through the process of making the chart. You want to simply know that when we have h of x equals x squared, it's this parabola. The graph of a quadratic equation gives us a parabola, and this one is opening upwards. Now let's look at these two transformations. We've got this blue transformation, the negative out in front. And when we put a negative out in front, that transformation says to reflect on the x-axis. So what that's going to do is this parabola, instead of opening upward, it's going to open downward. So this point, -1, 1 would become -1, -1. -2, 4 would be -2, -4, and so on. So I would get these blue points because of that reflection on the axis. So we're going to start with that magenta colored parabola. That's our original function. And then the negative out in front says to reflect on the x-axis. You know, a good way I remember this is that if I have a positive x squared, it's positive. There's not a negative in front of that x squared. It opens up like a smile, right? But if I have a negative in front of that, a negative parabola frowns, opens downward like a frown. Whenever we're doing a parabola, a quadratic, and we see a negative out in front, it's going to reflect on this x-axis. It's going to be like a frowning, downward opening parabola. So that's just a side note about the parabola. Let's look next at this -2. When I see that it's f of not x, but x minus 2, that's going to mean a shift. And it seems like it would shift left because negative is usually left, but you've got to get used to this, that when it's inside a parenthesis, it's actually going to go right. It's going to go right 2 units. So each of these points will go right 2. So the 0, 0 becomes 2, 0. The 1, -1 becomes 2 to the right, so 3, and so on. 4, 1, 2, 3, 4, and 5 would go down to the same y value. Notice that each of the points simply moves right. Oop, don't want to erase the graph. Each of the points moves right too. Let's talk for just a minute about why it's right too. Simply put, you want to remember that when we're inside the parentheses, we go opposite. So instead of left to, we'd go right to. But here's one way to see it. What do you remember solving an equation? Now I'm blending two things together, but they're closely related. Because if I had this x minus 2, if I were solving it to find its zeros, so if I set this x minus 2 squared equal to 0, when I go to solve it, I'd get x equals positive 2, right? Where did that come from? Because I set this factor, the x minus 2 to 0, adding 2 to both sides, I get x equals 2. But when I solve, I get x equals 2. X equals positive 2. And so the 0 is this positive 2, x equals positive 2, which is right from the 0. So you could see this when we set this x minus 2 to 0, this x equals positive 2 tells us that we move right 2 units. But either way that you look at it, this green function is our end result. Let me talk through one more time where I got that from. Started with the x squared, that's this upward opening parabola. And you know what, I could have done it in this order. I could have shifted right first. So I go right 2, and then it would have been this thing, right? But then when I open downward, let me erase that so it doesn't get so messy. Then when I open downward for this negative, we'd get the downward opening. So again, if we look at the colors, I reflected across the x-axis, so I took the magenta x squared and opened it downward and then shifted it right. I just wanted to show that for this one, we could have shifted right and then downward also. Well, I hope that this short video walking through the transformation of the x squared being flipped across the x-axis and shifted 2 to the right, I hope that the short video has helped you a little bit better understand that. Please do let me know if you have any questions or need further assistance with this.